Hi, Assalamualaikum and good evening. My name is Muhammad Iqbal bin Khairuddin. So this video demonstrates our ITT 440 project on socket programming using Docker containers. And in this project, we implemented client-server communication using both C and Python. So the system consists of a central MySQL database container, which is imported from Docker Hub. And each group member has their own pair of containers consisting of one socket server container and one socket client container. And these server and client containers are implemented using either C or Python, and they communicate using TCP or UDP sockets. And all containers communicate through a custom Docker network, and only the servers are allowed to access the database. Each server updates a different user record in the database every 30 seconds, where the points increase and the timestamp is refreshed. And the clients connect only to their corresponding servers to request the latest point, which are retrieved from the database by the server. And then next, I will show our Docker network. So we created a custom Docker bridge network called ITT440net. And this network allows all containers to communicate using container names instead of IP addresses. And then next, I will pass the Docker database to Khalid.
Thank you so much, Ikwan. Hi, my name is Khalid bin Shukri Talib, and today I'm going to present my part, which is the Docker database. So on this next part, I will explain the database container used in this project. We used an existing MySQL image from Docker Hub, running as a Docker container named MySQL_DB. All right, so This database, this database container is connected to the same Docker network as all server containers, allowing the server to access it using the container name. So now we will go into the show database to view more details on this. Okay, so now you can see here we can see that the available database inside the MySQL container. For this project, we used database called ITT440, which was created specifically for this assignment. So now we will try to select the ITT440 by using the command use ITT440, which is there. Okay. So I will now select the ITT440 database to show its content by going into show tables. And okay, so inside the ITT440 database, we have a table called scores, as you can see on the screen, which stores the data used by all server containers. So we can go deeper into the scores by using describe scores. The scores table contains 3 columns. As you can see, there is user, which identify each server, points, which stores the score value, data date time underscore stamp, which record the most recent update time. Each server container updates its own user record on this table. So if we go to select star from scores, as shown here. So wait, let it. Okay, so each row corresponds to a different server container. The point value increases over time, and the date time timestamp is updated every 30 seconds by the server containers. All right, that's all from me. So I will pass this to my teammate Jerry. Will explain further about the C, TCP, and UDP containers.
Okay, thank you, Khalid. Good uh, evening. My name is Jerry Dixon Anabusu. So now I will present my part, which is the C, TCP, and UDP containers. So for the first part is to show the TCP client source code. We will start with the C TCP client. So this program actually create a TCP socket using socket AF underscore inet salt underscore stream and connect to the server on port 5001. As you can see on the screen, the client resolve the server container name using get addr info, which allows communication through Docker networking. After connecting, the client send a request message, wait for the server's reply, prints the latest points, and then closes the connection. For the second part, we will want to show the TCP server source code. Okay, as you can see, next is the C TCP server. The server create a TCP socket and listen on port 5001. It uses select with a 30-second timeout. When the timeout expires, the server updates its assigned user record in the MySQL database. When a client connects, the server accepts the connection, query the database for the latest points, and send the value back to the client. For the next part, we would like to show the UDP client source code. Okay, so this is the C UDP client. Instead of establishing a connection, it sends a UDP datagram to the server on port 5002. The client waits for the server reply and print the received points. Okay. The next part is to show the UDP server source code. Okay. The server listen on port 5002 and also use select to update the database every 30 seconds while continuously listening for incoming UDP packets. When the packet arrives, the server retrieves the latest points from the database and sends the response back to the client. Now we would like to start the Docker. So we will use command start Docker container name, which is a start equal server. Okay. Okay. So the next part is to start the Docker client. Okay. So both server and client. And then the next part is to show the client log. Okay. And then finally, we would like to show the MySQL table. So we are using command select from score where user Ikpan, and then select from score where user Fadil. Okay, so next I will pass to Adele for the Python TCP and UDP containers.
Okay, thank you, Jerry. My name is Muhammad Fadil Nazrin bin Ahiruddin. Assalamualaikum and good evening. So I will continue for my part for Python TCP implementation. Okay, now let's move on to the Python implementation, starting with the TCP client. This program creates a socket using socket.af_inet and socket.sock_stream. It is designed to connect to our server on port 5003. Once connected, it sends a request message, retrieve the latest point from the server, and then closes the connection. And for the Python TCP server, it listens on port 5003 and run in a continuous loop. A key further here is the non-blocking mode. This allows the server to constantly check for new client connection without interrupting its main cycle, which is to update its assigned user record in the MySQL database every 30 seconds. When a client connects, the server simply fetch the latest point and send them back. And next is the Python UDP client. Okay, as you can see in your screen, it's create a UDP socket and send a datagram directly to the server on port 5004. The client then wait for the server response and print the received point on the screen. And now the Python UDP server. Okay, the Python UDP server also listen on port 5004 and utilize a non-blocking socket inside its loop. Similar to the TCP versions, it updates the database every 30 seconds while simultaneously listening for any incoming UDP packet to process. Okay, finally, let's see the system in action using Docker. Okay, as you can see in screen, first start the server container and then the client container using the Docker start command to verify that they are communicating correctly. We can check the client log with Docker log. To wrap up our demonstration, we check the final in the database and final result in the database by running a select query for user like Khalid or Jerry. We can see that the point have successfully increased and the time step are updated. This proves that our Python container are working perfectly with the central MySQL database. So in conclusion, we have successfully demonstrated a multi-container environment where both C and Python server can communicate with a shared MySQL database using TCP and UDP socket. This project highlight the importance of socket programming and how Docker can be used to manage complex networking between different programming environment. So that is all from our group. Thank you for your time and have a good day. Thank you.